The Magrathians are sentient beings that live on the completely undisturbed and peaceful planet called Magrathia. Individuals of this population can be born with either no ears and cannot hear, one ear and can hear half the time, or two ears that enable normal hearing. Magrathians are diploid organisms and mate randomly through sexual reproduction. The ear variation in this population is conferred by the presence of an autosomal gene that has two alleles which encode for three different phenotypes. Individuals with no ears have the genotype e. Individuals with one ear have the genotype big E, and individuals with two ears have the genotype big E. A study was conducted to observe allele and genotype frequency using population data. Genotype frequency can be calculated by dividing the number of the genotype by the total number in the population. Genotypic array was 0.25 big E plus 0.5 big E plus 0.25 e. The allele frequencies can then be calculated by plugging in the genotypic frequencies into the genotypic array. This would then give us the gametic array of 0.5 big E plus 0.5 e. In this instance, P equals Q equals 0.5, where P and Q are the frequencies of the big E and the little e alleles, respectively. This shows that the allelic frequencies are equal and the frequency of heterozygous individuals are the greatest. This result proves the population to be at Hardy Weinberg equilibrium for this locus. This means that all genotypes encoding for ear presence were equally fit as determined by its obtainment to the Hardy Weinberg equation P squared plus 2P Q plus Q squared. Genotype frequency related to ear formation are given in the table below. Recently, however, Magrathia was invaded by the terrible alien species known as Vogons. Vogons attempted to eliminate all Magrathians by reciting their awful poetry through an intercom on their spaceship. This attack strategy, however, only proved successful if the poetry was heard by the recipient. The longer the victim was exposed to such an awful reciting of poetry, the more likely they were to erupt into flames and perish. Survival against the Vogon invasion depended entirely on the level of exposure to Vogon poetry recitation. Since individuals without ears cannot hear anything, they were unharmed in the attack. The heterozygous population that can hear half of the time were less affected, but still experienced a few deaths largely caused by the recitation of haikus, short and deadly. And the homogeneous population with both ears was greatly impacted due to their level of vulnerability to the awful sound of Vogon poetry. A second observation of survivals from the first study examined how the genotype at the locus encoding ear development affected the survival of these Magrathian individuals after the Vogon invasion. The data of the new population numbers is recorded below. From this information, relative fitness can be determined by dividing each number of survivors for each genotype by the number of genotype with the greatest amount of survivors. From this information, the type of selection can be denoted as directional selection, additive effects, for the little e locus because the extreme homogeneous trait for no ears is most favored in comparison to the other extreme of having ears being unfavored. This means the population will be entirely homogeneous after an infinite number of generations. This type of selection alters Hardy Weinberg equilibrium because it alters the allele and genotypic frequencies of the population, causing a gradual shift towards one extreme over many generations. To observe this effect and predict future outcomes of this population, new frequencies after selection can be obtained by using the table method below.